Indeed. So polls are a way of estimating how many people fall into a certain category or think a certain thing. As we've been discussing already, and as I think you know, they're far from foolproof, and each poll has a different level of accuracy. One of the ways that we estimate that accuracy is through something called the margin of error. The margin of error basically is a way of expressing how accurate or generally inaccurate a poll might be. So as Adrian was just saying, we've talked about sample size, and the sample size has a direct effect on the margin of error. The larger the sample, the smaller the margin of error. That's what this is showing you right now. So when we see a margin of error, it's usually expressed as plus or minus some percentage points. So it's pretty typical to see something like plus or minus 2.3 or plus or minus 4.8, something like that. And what it's doing is it's describing how likely the sample is to be an accurate representation or an accurate reflection of the population, whatever that population is that the poll is actually polling. So it's telling you that each result, each percentage in that poll is in the range above or below that actual number that it's reporting. And we're going to talk about that in greater detail right now, because margin of error, I think, is probably the thing that we get asked about the most when people don't really understand a poll. So we're going to look at a quick example. Let's say we have a poll of registered voters, and we have a sample of 1,000, which, as you heard Adrian say earlier, is pretty typical. That's probably the most common sample. Now, for a sample of 1,000 people, the margin of error, based on that curve that you just saw, is plus or minus 3.4 points. So in this case, what we're asking in this poll is how many people plan to vote in the election and how many don't. And the result of the poll is really just an estimate of the actual number of people who are, in this case, planning to vote in the election or not. To understand where the actual number is likely to be, that is, what range is it in, we measure 3.4 points up from the estimate from the poll and 3.4 points down from it. So in this case, if 45% of the people in our poll say that they're going to vote, the margin of error tells us that with pretty reasonable confidence, the real number is somewhere between 41.6% and 48.4%. They're in this range. And that range is what we call the confidence interval. This is not a term you need to memorize or anything like that, but just so you know, that's what it's called in statistics. And that's the range in which the real number of people planning to vote in this election most likely falls. It's somewhere in that range. In other words, the real number of people planning to vote in the election is very likely between 41.6 and 48.4%. Most of the time, though, we're not looking at a single poll number in isolation. What we're actually doing is comparing two or more components of a question. So in this case, we might want to ask, are more people planning to participate in this election, or are more people planning to sit out the election? Now, at first, this really seems pretty obvious. The poll tells us 45% are planning to vote, 55% are planning not to vote. So it seems obvious. But remember that these are just estimates of the real number. And the real number for each one falls somewhere in the confidence interval for that result. So we actually have to compare the two confidence intervals to each other. Now here we see that there's space between the two confidence intervals where we've measured with that margin of error 3.4 points up and 3.4 points down from each result. Because there's space, this is telling us that the range of probable values for people planning to vote does not include the range of probable values for people not planning to vote. So we can be pretty confident that more people are planning not to vote than are planning to vote. But what if the results were just a little bit closer? What if 48% of people in our sample said that they plan to vote and 52% said they don't? In this example, even though the results have barely changed, they've only changed by a couple of points, now the confidence intervals actually overlap with one another. And this tells us that the range of probable values for people planning to vote includes some of the range of probable values of people not planning to vote. So in other words, the actual number of people planning to vote and not planning to vote might both be in that overlap area, this center area. So we can't be statistically confident that more people are planning to not vote in this election. Now, margin of error is also higher for subsets of the sample than for the whole sample. And that's because subsets are, obviously smaller samples of the overall bigger sample. This is really important to keep in mind when you're trying to compare groups within a poll. And it's actually a pretty high bar to clear in order to see a statistically significant difference. So one way to think about it is that the smaller the subset, the further away from the others or from the average it has to be statistically distinguishable from the others. So again, an example. Let's say that within our sample, 400 people are Democrats and 300 are Republicans. And let's say that 70% of Democrats say that they're planning to vote, while only 60% of Republicans say that they are. Now, it seems pretty obvious, again, that Democrats are more enthusiastic about this election than Republicans, but not so fast. We have to do the same thing here that we did before. We have to compare the two confidence intervals. Now here, because the margin of error for a sample of 400 is plus or minus 5.4, and the margin of error for a sample of 300 is plus or minus 6.2. These are very large margins of error. We have really wide confidence intervals. So even though the two estimates, that is 60% and 70%, are 10 points apart, which seems like a really big difference, there's actually still an overlap. So we can't be statistically confident that they're different, although it is pretty likely because that's a very small overlap. Now, before I hand it back to Adrian, I just want to note that, as Pew Research Center puts it, non-probability sampling, which is what we use for online polls, doesn't permit the computation of a margin of sampling error the same way that probability sampling does. So there's greater uncertainty about the accuracy of results from these samples, but they have some advantages over probability samples. And we've just talked, we saw in the chat, all of the reasons why those probability samples might not actually be very accurate. So on balance, we still think that the non-probability samples that we get from online polling, if they're done well, are still pretty accurate. When you look at a poll that's done online, you will see something that's similar to a margin of error, but it's not statistically exactly the same thing, but it's still an estimate of the error of how accurate the poll is.